So what we're working with today is solving absolute value inequalities. Remember that absolute value when we did equations, if I had something like the absolute value of x is 5, remember that we have positive 5, and then the other one is negative 5. So it's the same idea as what we're going to have, okay? But we need to remember that there's always two answers. And remember there's these steps we had. These were the steps. We had to get the absolute value alone. Remember, do not distribute into the absolute value. You plus or minus any numbers that are outside adding or subtracting. And then you divide if there's a number multiplying by the absolute value. And then after that, we break it down into two equations. Okay? So those are the steps that we have to have. Okay, so now let's get into what absolute value inequalities are. Remember, they're going to have two solutions. And one thing that's important is they cannot be less than or equal to or less than or equal to a negative. So we used to see that they can't equal a negative, but now they can be greater than a negative. They just can't be less than a negative. Okay? And the reason they can be greater than a negative is because the absolute value of 5 is always going to be greater than a negative, okay? So greater than a negative works. You can solve for that, okay? So if you see the word and, you're going to use a less than sign. If you have the word or, you're going to use a greater than. We will not spend a ton of time with these, but I want you to recognize what they should be. Okay, so let's try some problems. So this first one, absolute value of x is greater than 7. So the absolute value of x is greater than 7. But then here, I know that this is going to become negative 7 because that's what we did over here. But because it's an inequality, I flip the inequality also. So I change the sign and flip it. And so now when I graph it, I have 7, and it goes to the right. And I have negative 7, and it goes to the left. So it's an or problem. So just like here, this helps us know that they should go one way or the other. Okay, so same thing here. I'm going to break it down. The first one becomes less than or equal to 3. The second one becomes greater than or equal to 3 because when I change the sign, I also flip the inequality. Okay, and so I have a positive 3 and a negative 3. At positive 3, it's smaller, so it goes to the left. And at negative 3, it's greater, so it comes to the right. So this is why less than signs are ands. They become dumbbells. All right, here I have a negative, but it's okay because it's the absolute value of something that's greater than a negative. And absolute value is positive, and all positive numbers are greater than negative. So I have x is greater than negative 4. And then I have x is less than positive 4 because I changed the sign and I flipped the inequality. So I have negative 4, 0, and positive 4. And negative 4, it's an open circle going to the right. And at positive 4, it's an open circle going to the left. So it was a dumbbell again. Okay. So this is kind of an example on why we don't use this that often. Sometimes it's going to work and sometimes it's going to be different. So this works probably 90% of the time. But I just wanted you to see it just in case you see word problems with it. Okay, so now on this one we have the absolute value is less than negative 2. Well, this one's not possible, because an absolute value is always positive, and a positive is never smaller than a negative. So this one's a no solution. Okay? All right, so let's see if we can write and graph an absolute value for each statement. A number is more than 3 units from 0. So what might be helpful is if you start off by graphing it. So it's more than 3 units from 0. So it's not 3, but it's greater than 3, so it's an open circle. And then it's also more than 3 units this way. It's easier to understand if you always start with the positive one. So x has to be greater than 3. And because it goes to the left and right, we can make it an absolute value. Okay, so the next one, it's less than 4 from 2. So 1, 5, 6. Okay, so it's wanting you to focus on right at 2. So it's shifted its some, it's not in the center. Okay, so it's less than 4 away. So that's 1, 2, 3, 4. So it doesn't include 6, but it's there. I'm going this way. And then 1, 2, 3, 4 from here. So it's within 4 of 2. So now what we need to do is write our equation for that. Okay, so this one's a little tricky because it's not based off 0, it's based off 2. So I have to add or subtract something to give me something that will end up being at 6. So I have to be less than 6. And so if you think about it, if I have a 4 to get from 6, I'm going to have to add 2 on both sides. Well, the only reason I'm going to add 2 is if there's a minus 2 inside. So shifting to the right, we would minus 2. Okay, so now let's try doing some solving. Why don't you try numbers 1 and 3 by first of all breaking it down. So the first one's x plus 4 is greater than 2. And then x plus 4 is less than negative 2. So try 1 and 2, go ahead and solving it, and once you think you're ready, come back. Okay, so you should have minus 4 on both sides, and you get x is greater than negative 2. Minus 4 on both sides here, and get x is less than negative 6. And it doesn't say to graph, but we're going to go ahead and graph it because it's more practice. So at negative 2, it's an open circle going to the right. And at negative 6, it's an open circle going to the left. And that's it. All right, for number 2, you should have broken them down to 3x minus 6 is less than or equal to 9. And 3x minus 6 is greater than or equal to negative 9. So for both of them, you start off by adding 6 to both sides, and you get 3x is less than or equal to 15. And then to get rid of a times 3, you divide 3 on both sides. So x is less than or equal to 5. You can do the same steps over here, but because it's a negative, it's going to give you different answers. So negative 3, divide by 3, and x is greater than negative 1. So I'm going to squeeze in a graph right here. So I have 5 and negative 1. At 5, it's a closed circle, and it's less than. And at negative 1, it's a closed circle, and it's greater than. So there's your Dumbo. All right, when we get to problems 3 and 4, this would be as hard as they get. You have to get rid of outside stuff, so I first have to minus 8 on both sides. Now it looks like it might be a no solution because it is a negative, but it's greater than a negative, and all positive numbers are greater than a negative, so this problem can be done. So x plus 5 is greater than negative 7, and x plus 5 is less than negative 7. Then I minus 5 on both sides, and I get x is greater than negative 12. And over on the right side, I get x is less than, oops, I forgot to change that to positive. You see that? I should change that to sign to positive 2. Okay, so now it's at 2 and negative 12, and it's greater at negative 12, less than at 2. Okay, last one. Figure out what you would get rid of first. Yep, you get rid of the minus 3, the plus 3 first by minusing 3. And then I'm going to divide by 2 on both sides. And I have a negative, but I have to check and see if it's okay, because some negatives are okay. And this one is saying the absolute value is less than a negative 1. Well, an absolute value can never be smaller than a negative number, so this is false. So this is a no solution. So when you solve absolute value inequalities, remember you have to get rid of the outside stuff, and then when you break it down, But remember, on the right side, you flip the inequality and change the sign.